Good morning, students. Today's topic is miscellaneous compounds, part 2. First one is succinic acid. The molecular formula of succinic acid is C4H6O4. Okay, the molecular formula of succinic acid is C4H6O4. Succinic acid is a dicarboxylic acid. Okay, succinic acid is a dicarboxylic acid. It is a colorless crystal having an acidic taste. Okay, so succinic acid is a dicarboxylic acid. That's are the physical properties of succinic acid. Is a dicarboxylic acid. It is a colorless crystal. It has an acidic taste. The taste is acidic taste. Solubility. It is soluble in water. Okay, as succinic acid is soluble in water. The tricarboxylic acid cycle. So TCA in mitochondria generates succinic acid in the form of succinate. Okay, the tricarboxylic acid cycle TCA in mitochondria generates succinic acid in the form of succinate. So succinic acid is either produced synthetically or fermentation from bromas for human use. Okay, that's are the physical properties of succinic acid. Succinic acid is a dicarboxylic acid. It is a colorless crystal. It is an acidic taste. It is soluble in water. The tricarboxylic acid cycle, that means TCA in mitochondria generate succinic acid in the form of succinate. Succinic acid is either produced synthetically or fermented from biomass for human use. Next, the structure of succinic acid. Okay, then uses. It is used as flavoring agent in foods and beverages. Succinic acid is used as flavoring agent in foods and beverages. Then it is also used in foods as a sequestrant, buffer, and as neutralizing agent. So it is used as a flavoring agent and sequestrant and buffer and a neutralizing agent in foods. Then it is used as an intermediate for dyes, perfumes, liquors, photographic chemicals, alkyl resins, plasticizers, and a metal treatment. Okay, metal treatment, chemicals, and coatings. Okay, so the succinic acid is used as intermediate for dyes, perfumes, lacquers, photographic chemicals, alkyl resin, plasticizers, then metal treatment chemicals and coatings. Okay, then it is also used for manufacturing sedative, antispasmants, and antiphylam, and antiphlogistic, that means anti-inflammatory, then contraceptive and anti-cancer agents. So the succinic acid is also used for many medicinal uses: sedative, antispasmus, then antiphologist, contraceptives, and anti-cancer agents. Okay, that is the notes for succinic acid. The next topic is ethylene diamine. The molecular formula of ethylene diamine is C2H8N2. Ethylene diamine molecular formula is C2H8N2. Ethylene diamine is a clear colorless liquid having an irritating and ammonia-like odor. Okay, ethylene diamine is a clear colorless liquid and that it is irritating and ammonia-like odor. It is a flammable, then hygroscopic and fuming thick liquid. Okay, it is a flammable gas. It is a flammable liquid and hygroscopic and fuming thick liquid. Then it has a flash point. Flash point is means 9 degree Fahrenheit, and flash point means boiling point is 9 degree Fahrenheit and melting point is 47 degree Fahrenheit. It is corrosive to tissues and vapors are heavier than air. It is very corrosive. It is corrosive to tissue and its vapors are heavier than air. Then preparation. Industrially, it is prepared by the reaction of 1,2-dichloroethane and ammonia in an aqueous medium under pressure at 180 degrees Celsius. Preparation. It is prepared by the reaction of 1,2-dichloroethane 1,2-dichloroethane and ammonia in an aqueous medium under the pressure at 180 degrees Celsius. That is a structure of ethylene diamine. Okay. So ethylene diamine is a clear colorless liquid having a irritating and ammonia-like odor. Then it is flammable and hygroscopic and a fuming thick liquid. It has a flash point 9 degree Fahrenheit and the melting point 47 degree Fahrenheit. It is corrosive to tissues and to vapors are heavier than air. Preparation. It is prepared by the reaction of 1,2-dichloroethane and ammonia in an aqueous solution under pressure at 180 degrees Celsius. Okay. Then uses of ethylene diamine. It is used for manufacturing fuel additives. Then bleach activators and chelating agents and corrosion inhibitors. Ethylene diamine is used for manufacturing fuel additive, bleach activators, then chelating agents and corrosive inhibitors. Then second use, it is used as a solvent for preparing pharmaceuticals, fungicides and synthetic waxes. Ethylene diamine is used as a solvent for preparing pharmaceuticals, fungicides and synthetic waxes. Then it is used as a gasoline additive. This is the uses of ethylene diamine: manufacturing fuel additives and bleach activators, then chelating agents and corrosive inhibitors. It is preparing pharmaceuticals and fungicides and synthetic resins. Then it is used as gasoline additive. Then third one is salicylic acid. First we studied the topic succinic acid. Then second one is ethylene diamine. Then third one is salicylic acid. The molecular formula of salicylic acid C7H6O3. The molecular formula of salicylic acid is C7H6O3. Salicylic acid is a colorless crystalline organic acid occurring naturally in plants. So salicylic acid is a colorless acid. It is crystalline organic acid occurring mainly naturally in plants. Then chemically, it is synthesized from dry sodium phenoxide, that is sodium phenoxide and carbon dioxide followed by acid treatment. So the preparation of succinic acid is dry sodium phenoxide, that is sodium phenoxide and carbon dioxide followed by acid treatment. In its pure form, it is obtained as white needles for hot water crystallization. It is in its pure form, it is obtained in white needles for hot water crystallization. Further, the needles undergo sublimation at 155 degrees Celsius and melt at 159 degrees Celsius. Okay. Further, the needles undergo sublimation at 155 degrees Celsius and melt at 159 degrees Celsius. Then salicylic acid undergo decomposition about 200 degrees Celsius and yields phenol and carbon dioxide. Okay. Then salicylic acid is a colorless crystalline organic acid. It occurring naturally in plants. Okay. Salicylic acid is naturally occurring in plants. Chemically, it is prepared by dry sodium phenoxide and carbon dioxide by acid treatment. In pure form, it is obtained as white needle shape and hot water crystallization. Further, the needles undergo sublimation at 155 degrees Celsius and melting at 159 degrees Celsius. Salicylic acid undergo decomposition above 200 degrees Celsius and yields phenol and carbon dioxide. Okay, then structure. This is the structure of salicylic acid. Next, uses of salicylic acid. It is a bacteriostatic, fungicidal, and keratolytic agent. Salicylic acid is a bacteriostatic, fungicidal, and keratolytic agent. It is an anti-inflammatory agent. Salicylic acid is an anti-inflammatory agent. It is topically used as an antibacterial agent due to an ability to promote exfoliation. Okay, then salicylic acid is a bacteriostatic, fungicide, and a keratolytic agent. It is an anti-inflammatory agent. It is topically used as an antibacterial agent then due to its ability to promote exfoliation. It is used as a food preservative and antiseptic in toothpaste in small amounts. It is used as food preservatives and antiseptic in toothpaste in small amounts, small quantities. It is an ingredient of many skincare products used for corns, keratosis, pilaris, and warts. Okay, it is also an ingredient for many skin care products. Okay, these are the uses of salicylic acid. Next topic, ethanolamine. Next topic, ethanolamine. Molecular formula C2H7NO. The formula of ethanolamine is C2H7NO. Ethanolamine is a viscous and hygroscopic amino alcohol. Ethanolamine is a viscous and hygroscopic amino alcohol having an ammonia-like odor. The smell of ethanolamine is ammonia-like smell. It is a primary amine as well as a primary alcohol due to hydroxy group. So, it is a primary amine as well as a primary alcohol. It is synthesized. Then next preparation of ethanolamine. First of all, physical properties. Ethanolamine is a viscous and hygroscopic amino alcohol having an ammonia-like odor. It is a primary amine and primary as well as a primary alcohol. Okay. Then preparation or synthesis of ethanolamine. It is synthesized by the reaction of ethylene oxide with aqueous bromine. Ethylene oxide is reacted with aqueous bromine. Diethanolamine and triethanolamine can be produced by the same reduction structure. Okay. Ethanolamine is produced by or synthesized by the reaction of ethylene oxide with the aqueous ammonia. So, diethanolamine and triethanolamine can be produced by the same reduction structure. Okay, these are the structure of ethanolamine. Okay, CH2OH, CH2NH2. Okay, then uses. It is used as a surfactant and a fluorimetric reagent and for removing carbon dioxide and hydrogen sulfate from natural gases and other gases. Okay, and then it is used for sclerosing agent. It is a first generation nomenclature. It is a first generation monoethanolamine used as an antihistaminic agent. It is a first generation monoethanolamine used as a antihistaminic agent. Okay. Okay, students, today we will discuss. Then first one is succinic acid. The molecular formula of succinic acid C4H6O4. Then next topic, ethylene diamine. The formula of ethylene diamine is C2H8N2. The next topic is salicylic acid. The molecular formula of salicylic acid is C7H6O3. Then next topic is ethanol amine. The molecular formula is C2H7NO. Okay, students. Thank you.